Hello everybody. Before we dive in, I want to mention that this video might run a bit long, so if you can spare the time, I guarantee you that you will gain valuable insights applicable to your job. So today I'm gonna guide you through the process of setting up a high availability website on AWS. You can also follow these steps, the same steps, to configure an application in your production environment with your own risk, but at least make sure you spend time in the security side and adjust that configuration to your own needs. So let's start. This will be our infrastructure. Why I call this system highly available? Because it relies on 3 AWS zones. So basically these zones are clustered data centers. If one of the zones goes down, then you will still have other zones up and running. So at first, we're going to create a custom VPC, Virtual Private Cloud. This will be our VPC. And in this subnet, the purpose of VPC is to get the security through the private subnet. What I mean is, like, we are going to have 2 subnets in every zone. As you can see, that public subnet and private subnet. The web servers, these EC2 instances, imagine that they are web servers. The web server will sit on the private subnet, and the users will only access to this website through load balancer. And this load balancer will sit on the public subnet. The users, first they will go to the internet gateway, then load balancer, and the load balancer distributes the load among these 3 web servers. But we are going to create one web server, one instance, like to keep this tutorial short, but of course you can create 3 of them as well. Every subnet will have own route table. Public subnet route table will forward traffic to the internet gateway. And let's say that there's a route table, so the route table will forward traffic to the internet gateway. But private subnet route table will forward the traffic to the VPC NAT Gateway. So basically NAT Gateway is used to connect the instances that are created in the private subnet to the internet. So route table will forward traffic to the NAT gateway, and then from the NAT gateway we're going to access to the internet gateway, so basically to the internet. And another thing is that you can easily SSH to your public subnet from the internet because it's public. But what about private subnet? First of all, by default, all subnets within the VPC can communicate each other. For example, let's say that you have created an instance in the private subnet, for example, this instance, and you can SSH to the instance from another instance that's created in any subnet. For example, you can access to this instance from this one, it doesn't matter. You can also access to this instance from this one, or you can also access to this one from this one. So basically, you can communicate within the VPC. But what if you want to connect your instance that is in the private subnet from the internet? So for that, we're going to use jump server. So this is called jump server. We will create it in public subnet. So first we will SSH to this jump server. Imagine that you are here and you're going to go through internet gateway and you're going to SSH to jump server. Because it is in the public subnet, so we can easily access that. And from the jump server, we're going to SSH to our instances that sit on the private subnet. In this diagram, all the components are free except NAT Gateway. So if you need high available NAT Gateway, then you will need to create NAT Gateway in every zone. But since NAT Gateway is not free, I will create it only in one zone, in any, like one of the public subnets. Also, you don't need to worry about the cost of NAT Gateway, since we are doing it for learning purposes. After we have set up everything, we're going to destroy NAT Gateway. So if you let it run for one full day, let's say, it will cost you around $1, which is not a big deal, I think. For us, it will only take less than an hour, so I guess it will be around 0.05 USD. To sum up, we're going to have AWS region, then inside the region, we're going to have VPC, Virtual Private Cloud, and in that Virtual Private Cloud, we're going to create 6 subnets, and then we will create one NAT Gateway. And we also need to have Elastic IP, which will be attached to this NAT Gateway. we will have also two route tables, one for public subnet and one for private subnet. If right now it seems like a bit confusing, don't worry, because you will understand everything when we start building the infrastructure in AWS console. I think we just planned everything. Now it is time to use AWS console and set up this infrastructure. Let me switch the tab. So I'm gonna use this region, EU Central 1, but of course you can select any region, but just make sure that you're gonna have like at least 3 available zones. I will type VPC and go to the VPC dashboard. Go to VPC. So for every region on AWS, they have at least one default VPC. So this one is default, or can you see that? So default VPC is yes. I just would like to mention that you should keep in mind that you don't delete this default VPC. So just for safety, what I'm gonna do is I will type here, this is default VPC. Let's save it. And every VPC has its own subnets. So if you go to these subnets, and they're also distributed in all 3 zones. For example, EU Central 1, A, B, and C. These are the zones. And how I know that they are public subnets, you can check it actually by looking at the root table. For example, let's take the first one. If you look at the root table, we're gonna see that we have 2 root entries here. The first one is local. It means that it will route the traffic within the VPC. But we have also this CDR notation. So basically it means every IP, all the IPs, and in this case it will route the traffic to the internet through this internet gateway. That's why these subnets are public subnets. Now we're gonna create our custom virtual private cloud. So I'm gonna go to your VPC section, and we're gonna create VPC. So VPC only, the CDR notation will be 172.25.0.0/16. And that's it. Maybe we can also give the name, of course. I will say BugX VPC. And just create your VPC. So it is created. Now we have 2 VPC. And then we have to create the subnets in that VPC, of course. I'm gonna say, let's go and check it. So I'm gonna say create subnet. And we have to select our VPC. Make sure that you select this new VPC. And we are gonna create all 6 subnets at the same time. So I will say that the first subnet name, let's say BugX public subnet 1, and CDR notation will be 172.25.1.0 and /24. So this will be our first subnet. So basically, if you go to the diagram, you will see that we have 6 subnets. So 1, 2, 3 is the public subnet, and 4, 5, 6 will be the private subnet. So I'm gonna copy this one. And also we're gonna distribute these subnets in the zones. So I'm gonna select 1A, then add new subnet. So this one will be 2. Let's select a B, and here it will be 2. Then the third public subnet 3, and let's select the last zone, and now it will be 3. Then we have to create the private subnets. I'm gonna say private subnet 1, the CDR notation will be for the first private subnet, and let's select the zone 1A, and the second one will be 2, CDR notation will be 5, and select the second zone, second available zone, and the last one will be 3, and this will be 6. I think that's it. Yes, we have selected this new VPC. Everything seems correct. Not correct actually. Yes, it's correct. I think privilege, and privilege. Okay, let's create subnet. Great, we have created all the subnets, but this public subnet, so we have 3 public subnets, right? So these public subnets are not public yet. So to make them public, we need to create a root table and attach it to these subnets. But before that, we should create Internet Gateway first, because we're gonna attach Internet Gateway to the root table. So I'm gonna go to the Internet Gateway. So this is the default Internet Gateway that's attached to default VPC. Let's call it default actually. Default VPC. And I will create another one. I'm gonna call it BugX Internet Gateway, and just create it. It should be VPC actually, not. It should be actually Internet Gateway, not VPC. Let me correct it. So we have 2 Internet Gateway, and as you see that it's not attached. And I will select it and I will attach the VPC. Make sure that you select BugX VPC and attach it. So it is attached, everything seems correct. Now we're gonna go to the root table, and we see that there are 2 root tables. One is default and the other one is created automatically. You can see basically the second one is default one, and the first one is created automatically when we create the VPC. And if I select it, if I go to the roots, you're gonna see that it has only one root entry, which routes the traffic within the VPC. Now we're gonna create another root table. I'm gonna create root table. I will call it BugX, let's say public root table, because we're gonna have 2 root tables, one for public subnet and the other one with for the private subnet basically. And select the VPC, make sure you select the BugX, create root table. So select root table, go to the subnet associations, and here we're gonna edit, and we're gonna select all public subnets to 1 and the third one. Save it. So right now it has 3 subnets, and then we have to edit this root table because we have to create another root entry that forwards traffic to the internet. So I'm gonna edit routes. I will add a new route, and I will say for every IPs, and we're gonna select Internet Gateway. So the new Internet Gateway that we created, save changes. Everything seems okay. Yes, right now we have 2 root entries. It means that we can finally say that our public subnets are really public. But if you launch instance in these public subnets, they will have access to the internet, but you will not access to your instances from the internet because they will not be assigned any public IP. To make it work, we just need to enable auto assign public IP in the subnets. So I will go to Subnets. Let's start the second one. I will edit subnet settings, and here I'm gonna enable this auto assign. Save it. Then the first one, enable save, and the last one is public subnet 3. Let's enable it as well. Okay, that's it. So we have done everything for the public subnets. It is time to work on private subnets. So we will do the same steps, but this time we will have NAT gateway instead of internet gateway. So NAT gateway will have static IP because that's how it will connect the internet. And that's why we should allocate one elastic IP. So I'm gonna go to elastic IP. Where is that? It's here, elastic IP. Allocate elastic IP. And we can add a tag. Let's say name, and let's call it BugX NAT elastic IP, and allocate. That's it. This is our public IP. Now we're gonna attach it to NAT gateway. So basically, first we need to create NAT gateway. Go to NAT gateway, create it. So I'm gonna say BugX NAT gateway, and then we should select the subnet. So the thing is that the NAT gateway itself is used for the private subnet, but it should sit on the public subnet because it will access to internet through the internet gateway. So I will host it in public subnets. Let's say public subnet 1, but you can choose any public subnet, it doesn't matter. And then select elastic IP. So this is the elastic IP that we have created, and that's it, create it. So right now it's in pending state, so it will take a few minutes to create this NAT gateway. Okay, it is created. Now I'm gonna create a root table and attach it to NAT gateway. So I'm gonna go to the root table. Let's create new one. I will call it BugX private root table. Select VPC. Make sure you select BugX VPC. So basically everything we're gonna create, it will be in the BugX VPC. So create it. Now I'm gonna associate all the private subnets. So let's select one by one. Save it. Okay, that seems good. Then we're gonna add one root entry. Edit routes. So all traffic will go to NAT gateway basically. This is the NAT gateway that we have created, and save changes. So basically this rule means that the traffic will be routed through the NAT gateway, not directly from the internet gateway, and that's why our subnets will be private. And I will also enable DNS hostname for the VPC, so that when we create instance within the VPC, we will get also DNS hostname. So just go to VPC, edit VPC settings, and here enable DNS hostnames. And that's it. Since we have done all the network stuff, now it is time to create jump server or jump host. So we have this server. We're going to use this server to connect our instances that are hosted in private subnet. This is very common approach because it's very secure. And if you still have some questions about jump server, you can just Google it, and I'm sure that you will find tons of articles which explain it in a best way. So anyway, let's first create security group for the jump server. So I'm gonna go to, basically we need to go to EC2, and here we're gonna create security groups. These are the default security groups. We're gonna create a new one. I'm gonna call it, let's say, BugX jump server SG security group. and do that here as well. So we have to choose the BugX VPC, and as an inbound rule, we have to be able to SSH to this instance. So I'm gonna choose SSH, and where from the my IP. Of course, you can choose anywhere, but just for the safety, I'm gonna choose the my IP. That's it. Just create security group. Before creating the instance, I will also create a new key pair. Let's here we're gonna create new key pair, basically SSH keys. I mean, so I'm gonna say BugX jump server key, create key pair, so it will download it. Now let's go to instances and create this EC2 instance, the jump server. I'm gonna call it BugX jump server, and I will choose this Amazon Linux AMI. It doesn't matter, actually you can choose Ubuntu as well. So I'm gonna choose the new jump server key. Then we have to select the existing security group, but before that just click this edit button, because you need to change this default VPC to BugX VPC. And since we are gonna create it in a public subnet, we have to choose a public subnet. You can choose any of them. I'm gonna choose the public subnet 1. Auto-assigned public IP enabled, so we're gonna have public IP. And security group, I'm gonna choose this group that just we have created. So that's it. Launch instance. It is launched. This is the new IP, public IP that we get for this instance. Okay, right now it's in the running state. I will try to connect to our instance. So I'm gonna use my terminal. I'm gonna use SSH. I will use this new key pair that we just installed. So it is BugX jump server. So I have two key, because first of all I have created this one like when I prepared this tutorial, but right now we have the new one, which is this one. So I'm gonna use it, and then we have to use the username and IP. Of course our IP is this one, and for Amazon Linux instance it is like the user will be EC2 user at our IP. Yes, let me a bit increase the size. So it says this private key will be ignored. Why? Yes, we have this permission problem because I'm gonna show you. As you see that for user we have read and write, and for others and group we have read, but it doesn't need to have read. So I'm gonna use change mode. Then let's say 600 and downloads by his jump server 1. Now we have only read and write for the user. I'm gonna try again. So we have connected to our instance. Uptime, it's up for 2 minutes. Since we have successfully connected to our instance, it means that our public subnet is working. Now it is time to launch instance in the private subnet and connect to that virtual machine from the jump server. So from this server, we're gonna connect to that instance. Basically, we can see it also in this diagram. So right now we have created this jump server in the private public subnet, and then now we're gonna create a new instance in the private subnet, and we're gonna connect to this instance from this jump server. Okay, let's do that. First, I'm gonna create a new key pair for that instance. So I will say BugX web, let's say key, create, and then we have to create security group as well. But before that, maybe we just copy the new key to the jump server first. So I'm gonna, let's exit this one. And what we're gonna do is we're gonna copy this new key. It should be, the command will be scp, and we're gonna copy the new key. To this jump server, and let's say that it will be home EC2 user. I think it's copied. Let's check it. So we are in the jump server, and if I do LSL, yes, we just copied the new web key to this instance, and now we have to create a security group. I'm gonna call it BugX web server security group. Let's do the same thing here, and we're gonna choose the BugX VPC, and as an inbound rule, we're gonna say SSH to this instance from where actually we have to select the security group of the jump server, because we have to connect from the jump server to new web server instance. So I think that's it. I'm gonna just create security group, and then let's go to instances, and we're gonna launch new instance. I'm gonna call it BugX web server. Let's select Amazon Linux again. Select key pair. Now it will be VIP key, and of course we have to select a new VPC. And subnet, now we have to select the private subnet, so I'm gonna select private subnet 1. So as you see that it is disabled, so we are not gonna have public IP, but we will have private IP. And existing security group, it will be new yes, web server security group. That's it. Let's launch the instance. So we have jump server, and we have just created a new BugX web server which sits on the private subnet. Now we are gonna connect to this instance from jump server. So let's see. Okay, it's running. I think we can check. So right now we are in the jump server. I'm gonna use SSH. Let's use the new key that we have downloaded. I mean, copy to this instance. So we're gonna use EC2 user at. Now this time we are gonna select the private IP, because as you can see that it doesn't have any public IP. So I'm gonna select this one. Yes, seems it works. Okay, it says permission denied. Again, the same error. We have to use change mode 600 to this key. And let's do SSH one more time. So we just connected to the instance that sits in the private subnet. So it means that everything works. And this virtual machine is the web server for us. So what I'm gonna do is I'm gonna install Apache HTTP, install. So the first, let's go to root user, and I'm gonna use sudo yum install httpd y, and it is complete. Now we're gonna enable it, systemctl, enable httpd. Let's say no, so it will run as well. And if we do systemctl status httpd, so it is active and running. And I will just create a simple index HTML file. So I'm going to say echo, let's say welcome to my AWS VPC project. and I will send this line to var www.html index.html file. That's it. So we have a web server which serves simple web page, but it's not accessible from outside because right now it sits in private subnet and doesn't have any public IP. That's why we are gonna create a load balancer in public subnet, and the web server will be accessible from the load balancer. Basically, we're gonna do this diagram, right? So users will go to the load balancer, and from the load balancer, we're gonna go to our instance that sits on private subnet. So basically to our web server. So let's do that. So here we have to create a target group. So target group basically is our new instance that's created in this private subnet. So I'm gonna say create target group. Let's call it BugX target group, and make sure you select the BugX VPC, and everything seems correct, I guess. Next. And here we have to register the targets. So our target will be just BugX web server. Include as pending below. Create target group. I believe that's it. So load balancer, it's not created yet. Now we're gonna create load balancer. But of course for the load balancer, we have to create security group as well. So let's do that first. Create security group. Let's call it application load balancer security group. And we have to select new VPC, add rule. Since it's a load balancer, it should be accessible from everywhere. We're gonna select the port 80, basically HTTP, and it will be accessible from anywhere. Also for the IP6. So I guess that's it. Let's create. And now we have to create the load balancer itself. I'm gonna create load balancer. I will select application load balancer, and let's give it a name, BugX application load balancer. And so we have to select the new VPC. Let's select all zones, but make sure that you select public subnet. So let's select, yes, okay, first we're gonna public subnet 2, and here it will be 3. And as a security group, we have to select the new security group that we have created. It will be application load balancer security group, and it will route all the traffic from port 80 to our target group, which was the instance that sits on the private subnet. I guess that's it. Let's create the load balancer. It should take some time. Right now it is in provisioning state, so it's gonna take a bit time. So the state is active, so it means that the load balancer is created. So according to our diagram, if the user goes to load balancer, then it should redirect the user to the web server, right? So if we copy the DNS name and put it here, it should redirect us to the web server. And let's see what happens. Okay, it seems it doesn't work. We just got timeout. I know the reason actually, and I hope you also know it. The problem is about the security of the web server instance. So let me go to security groups. We have web server. As you can see that as an inbound rule, we only allowed port 22 from like security group of the jump server. So basically from the jump server. But our server, web server, should be accessible from the load balancer as well on port 80, because web server runs on port 80. This HTTP server runs on port 80. So what I'm gonna do is I'm gonna say hello HTTP from the load balancer security group. Is this one, and save the rules. That should be implemented immediately. Let's refresh the page. So yes, that's it. It means that it worked. We have configured the whole VPC, and I really hope that you have learned a lot of things. So if you find this video useful, then you can subscribe for more videos like this one. So if we are done, I suggest to delete everything that we have done. At least delete NAT Gateway and release Elastic IP, because otherwise they will cost you, AWS will cost you money. So let's do that. I'm gonna go to VPC, and here we are gonna delete the NAT Gateway. To delete NAT Gateway, it will take some time actually. Confirm. Okay, it seems it is deleted. I'm gonna go to Elastic IP, and we have to release this IP. That's done. Let's also, now let's go to load balancer. Let's delete the load balancer as well. Delete load balancer. Confirm. It's deleted, and I'm gonna stop all the instances. And the last thing, what we're gonna do is we're gonna delete the VPC itself. So VPC. Make sure that you delete the new VPC that we have created, not the default one. So I'm gonna go to actions, delete VPC. It says unable to delete. Okay, it seems that the instances are not shut down yet, so we're gonna wait a little bit. Okay, finally we're gonna delete it. Type delete. So, okay, that's it. We just deleted everything. So that's all about this project. Thanks for watching, and good luck.